All right, this is topic 2 and it's on the periodic table. So this is a little video on the periodic table. I'll post it on the Google Classroom. It is from Crash Course. They are a good YouTube channel, I guess, to be able to see, be able to learn a little bit about certain topics in science. They also have them on other subjects as well, so if you haven't seen them. The only thing is they sometimes talk really fast, so they give you a lot of information in a short period of time. But you should check that out, and I'll post it on the Google Classroom. So the periodic table of elements, it says elements are arranged into columns, which are the vertical, and rows horizontal, according to their reactivity and their mass. So reactivity is the vertical. So the higher up on the periodic table, the less reactive you are, and as you go down the periodic table, it becomes more reactive. I think that... Oh, I can do that. So the vertical columns, their reactivity. And the horizontal, that is mass. So as you go along horizontally, this way, the mass goes up. It says reactivity decreases as you move left to right across each period, while mass increases as you move top down through groups. Mass also increases from left to right. All right, so that's sort of how the periodic table is set up. So if we look at the mass of like hydrogen, which is number 1, it's the lightest on the periodic table. And as we move down the numbers, everything becomes heavier, basically. That's all I want you to know from that. So the periodic table of elements, this is elements that are grouped together tend to have similar properties. So if we look at the different groups, and that's in the color-coded part of it, they all have similar properties. So the very first column there, alkali metals, they're extremely reactive. They're rarely found in pure form because of how easily they react with other elements. So if you look at like lithium, sodium, potassium, as you go down that rubidium, cesium, francium, all that row, you're never going to find them alone because when they're open to the air, they'll react. So they'll react with oxygen, they'll react with water. So it's really hard to find them in a pure form. The second column there is alkaline earth metals. They're less reactive than the alkali metals, but they... so easier to find in a pure form, but again, still do react with air and water like the alkali. All of that yellow area, those are our metals or our transition metals. I don't know why they didn't call them that. They're not very reactive. They're normally pure or often found in nature. They're good conductors of heat and electricity. They can be bent and polished, and most are solids at room temperature. One exception to that is the one you see in green here, or blue. That at room temperature is liquid, and that's mercury. Non-metals are in that blue area. They're poor conductors of heat and electricity. They're dull, brittle, normally gases at room temperature. And then noble gases are the very last row there. They are non-reactive elements. They're like the coolest elements on the periodic table. I always like to say that. They're the cool kids. These guys. Like, everyone wants to be like them. And they don't react with anything else because they're already like I guess, complete, is the best way to say it, is they're complete. They're already full. They don't need anything else. Where all these other elements, they react because they're like missing something. They're missing electrons or whatever it may be, and they want to be like the noble gases. They want to be like the cool kids. So they react with other things to become more stable or whole. Okay, so that's all that we need to really go over on the periodic table. But I'll continue going on to topic 2. Topic 2 is on compounds. So it says the periodic table lists all of the elements known to man, and a molecule is made up of 2 or more different elements, is known as a compound. Most substances in our world are compounds. So compounds are made up of more than one element together. And like it's said on the periodic table, a lot of things don't exist in a pure form. They're normally in a compound. They react with something else. Water is our most common compound. It's hydrogens and oxygens. We've got 2 hydrogens and 1 oxygen to make up water. That's H2O. Sugar. Sugar is a really big molecule. It's got C6H12O6. C is carbon, and that means there's 6 carbons in the molecule, 12 hydrogens, and 6 oxygens. So all of those are connected together to make sugar. And then carbon dioxide, that's something that we breathe out. That's what's showing in this picture. It's got 1 carbon and 2 oxygens. So something to note here is when you look at an element or a compound, the number right after the letter is going to tell you how many there is. If we look at CO2, if we look at carbon, there's no number below carbon. So there's no number here. Whenever you don't see a number below the carbon or behind it, that just means there's 1. Okay, it's not 0 because they wouldn't write C there. There's only 1. We don't need to write 1. We would only write it if it's 2 or more. Okay. So the uses of compounds, it says we use compounds every day without realizing it. Methane or natural gas, CH4, is used for heating. Citric acid or lemon juice, C6H8O7, is used for flavoring in our foods. Ascorbic acid or vitamin C, C6H9O6, is required by our bodies to live. Sodium chloride or table salt, NaCl, is used for cooking, and really it's in a lot of our foods. And then we exhale carbon dioxide. These are all just examples of many different compounds that exist in our life, and there's a whole lot more. So we can definitely could go on forever in talking about compounds that we see in our everyday life, but those are just an example of some of them. So compounds are all around us. Even like any sort of plastic, that's going to be a compound. Not natural compound, but it is going to have elements bonded together. So how we name these compounds, this is just as each element has its own name, so does each compound. A chemical formula is used to represent the number and type of atoms in various compounds. Letters tell you which elements are in the compound, and then the subscripts are those little numbers, like I said below. Those are going to tell you how many of each of the atoms exist in the compound. Subscripts, letters, tell you the state of matter. Okay, so they're talking about this. So if you see the little letters at the very end in brackets, it might say L for liquid, S for solid, or G for gas. Okay, so letter tells you what type of element it is. Subscript number below tells you how many of that element there is. And then the last part is going to tell you the state of matter. So there's a video here on naming compounds, and I will post that in the classroom. This is another example. It says chemical formulas for monosodium glutamate, commonly known as MSG, which is a type of seasoning in our food. You find that in a lot of like Chinese foods. It's NaC5H8NO4. That's a really big molecule. This indicates that 1 atom of sodium, 5 atoms of carbon, right? So 1 sodium, because there's no number below it, 5 of carbon, 8 hydrogens, 1 nitrogen, because no number, and 4 oxygens make up what we know as MSG. It also tells us that MSG is solid at room temperature. So that's S at the end is telling us that it's a solid. Okay. In total, then, each MSG molecule is comprised of 19 atoms. So if we add up all of the atoms that exist there, we can figure it out. So I'm just going to write this out. So Na, there's 1. This is not the best way to write it. I'm going to write 1 and then I'm going to write Na below it. Carbon, we've got 5. Hydrogen, we've got 8. Nitrogen, we've got 1. Oxygen, we've got 4. And that's it. So if we add that together, 8 plus 5 is 13. Plus 1 is 14, 15, 16, 17, 18, 19. Yeah. So 19 atoms in total in MSG. Okay? So that's how we're finding out how many are in there. It says compounds are generally named according to their chemical formula. However, common compounds also have everyday names. So when we're looking at compounds, they don't always have their sort of scientific name, I guess you could say. So CaCO3, if we were going to name that scientifically, or sort of how we do in chemistry. We would name that calcium carbonate. Ca is calcium, CO3 is carbonate. But we know that in life as chalk, okay? NaHCO3, that's sodium bicarbonate, but we just know that as baking soda. So certain compounds have everyday names, and I guess, I don't know why, but that's just the way that they do it. So we don't say, oh, you're writing on the board with some calcium carbonate. We just say you're writing with chalk. It's just, I guess, an easier way to talk about these compounds. It says decomposition reactions. Because compounds consist of more than one element, they can theoretically be broken down into said elements. This is accomplished through a process known as decomposition reactions. One common way of separating these elements in a compound is through the application of electricity. This process is called electrolysis. So what this is saying here is that there's in certain elements we can break them down, I guess, through a chemical reaction. So if we have a compound, and I'm going to do H2O because that's the one that they're talking about. If we add electricity to water, we can break apart the H's and the O's. So we would have H2 and O2. Or we'd have hydrogen and oxygen. Okay, so that's all this is saying here, is that we can break down these compounds. We can break them into their parts. If we had NaCl, if we wanted to break it, we would break it into Na and Cl. Okay. Don't worry about those numbers that I'm writing about it. That is the way that you write it, but it's not important to this class. Just note that this is what decomposition means, is that we're just breaking compounds into parts. So the example here, it says water can be broken down into hydrogen and oxygen via electrolysis. Not the most exciting decomposition reaction, but one of the simplest we can observe. And there is a YouTube video there that I will post for you to watch. Other decomposition reactions occur with the aid of a catalyst, and this is one of a more exciting one. This is, I guess I will post that as well. This is elephant toothpaste. And you guys may have seen this in the past or somewhere along the lines. But basically, breaking some of these things down, sometimes you need to add something else to it to help it do that. And I guess you did do that with water because you added electricity. You can add other elements or compounds but to help things break down as well, and that would be elephant toothpaste. So I will post that video as well. But after you go through this topic 2 section in chemistry, you can do the check-in that I will post. All right, have a great day.